Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to discuss the queue data structure. Queues are a high-level linear data structure that we use when we want to model things that occur in order. So we give priority to that first item and then work our way backwards until we reach the last item. So that front item, or the oldest one that was added, is going to be the one that gets helped first because it had been waiting the longest. And you can think of a queue as a queue or a line in real life. If you go to the store and you're waiting to check out, the first person who got there is going to be the first person who's helped by the cashier. And this is what's known as FIFO, or first in, first out. And this is the fundamental aspect of a queue and why we use them. We want to handle that first item, or the oldest one added, because they were there first. They should get the priority. This is in contrast to a stack, which is LIFO, last in, first out, where it handles the most recently added item. So let's visualize a queue. An in queue is where you add an item to the queue. So we in queue front, then in queue mid, then in queue back. Then we DQ front, DQ mid, and DQ back. So the oldest item, or the first one added, is also the first one that is removed and used. So the fundamentals of a queue is handling it in FIFO order. We in-queue them, and then the first item added is at the front of the queue, and then works its way to the back where the last item is the oldest. A queue is a linear data structure, so it has this order from first to last. It's also higher order, so it's implemented using other data structures. The most common way to implement a queue is using a linked list. You might think, oh, I could probably use an array as well. But actually, when you add an item to the front of an array, when you in-queue it, this would actually be an O of n linear time operation, which is actually not what we want with a queue. It's not optimizing around first in, first out methodology. So you can maybe use it in an interview and just acknowledge that it's O of n so you don't have to implement a queue, but it's always something to keep in mind. So you may be wondering, since it's higher level and we implement it using other data structures, what's the value of this? And the reason is, one, we can really model the aspect of the queue in our code and show explicitly why we use it. We want to use priority. We want to give importance to this first item, or the oldest item added, and handle the items in order. And then we can also optimize our operations around this FIFO methodology. So we can in-queue in constant time, or add an item in constant time, dequeue in constant time, or remove an item, or we can peek, which is looking at this front first item in constant time. And then a queue itself just holds n items, so it's O of n space. So the pros and cons of a queue is that the pro is you get fast access at the ends. The first and last item, or in-queue, dequeue, are all constant time, so you can work very fast where these operations matter. It's also ordered. You have these items ordered from oldest to newest, where you always work with the oldest first. The downside to a queue is slow lookups. So if you want to find an item in the middle of the queue, you have to dequeue each item until you come to the one that you're looking for. And this is going to be a worst case O of n linear time operation. So if you ever need access to anything other than the front item, then the queue is not going to be a good choice for your data structure, and you're going to want to consider something else. So we see queues in software quite a bit. When your CPU is handling processes, it's actually using a queue. So the first process that appears is going to be the first one that your CPU handles. It also happens in events and messaging queues. So you may have heard of things like RabbitMQ, and this is a way to just handle events that come in order, and you process them in the order that you receive them. Another example is caching, or specifically an LRU, or least recently used cache. You want to remove the items that aren't used often. So as an item's used, it's added to the back of the queue, and then when you need space, items at the front of the queue that haven't been used much will then be removed. Another very prominent implementation of the queue is the JavaScript event loop. So this is how JavaScript gets its asynchronous behavior. As your asynchronous events finish, like promises or callbacks, they're added to the back of the queue, and then JavaScript will handle them in the order in which it receives them. And finally, breadth first search. This one you might not quite understand yet, but you will when we implement trees and graphs and really understand how to walk through them using this breadth first search manner, which is built entirely on top of a queue. So in interviews, one of the common ways to use a queue is actually to build a stack. Stacks and queues are very similar. The difference is that queues operate in FIFO, or first in, first out, and stacks operate in LIFO, or last in, first out. But you use these properties to implement a stack with a queue, or vice versa. Another common example is task scheduling, or ordering items. This is fundamental to a queue, and just knowing how to do this in your interview and handling items that are the oldest and giving those the highest priority is going to be fundamental to solving the problems. And finally, caching or storing some fixed number of items. We already said in real life that queues are used to implement an LRU cache, and you can just do something similar in your interview. Alright, and that's our introduction to queues. Now we're ready to dive in and implement one, and also work our coding interview questions solving with queues.